Guys, I am going to get started, and we did leave off on Wednesday with that last one. With that last one to cover from 8.5, and it had a couple of things I wanted to make sure that we understood why the graph is what it is. So let's look at number, whatever this last one is, number 18 in 8.5, and then we'll move on to 8.6, which is actually real light compared to 8.5. Thank goodness. Okay. Okay, so here is the rational function for number 18. And the reason, now we do have graphing calculators, so why have we not just been putting all of these in our graphing calculators and choosing the graph that best matches it when we get to that point of the problem from there? And this is why. I want to show you how to put it in your graphing calculator and why you put it in like that. Now, remember, I'm going to work this just like I worked the other ones. I'm going to find the zeros of the numerator and the denominator because remember, they help me with several different things. They help me with the domain, the vertical asymptotes, the X intercepts. They help me with all of that. So I'm going to start off by finding the zeros first. Now, this numerator, and I'm going to show it in factored form and use my quad program anytime I have an X squared. Now, this one is X squared. I can put it in my quad program, which would tell me that the zeros, if I put this in my quad program, would be 0 and -6. The reason for that is if I did factor this, it would show me, I would pull out a greatest common factor of X, put in parentheses what would be left if I took an X out of both of those, which would be X plus 6. And then if I set those equal to 0 and solve them, that's where my two zeros would come from, right? They would come from setting this equal to 0, which would just give me 0. If I set this equal to 0 and solved it, it would give me -6. So there would be the zeros of the numerator. The zeros of the denominator, again, you'll see that all three of these terms have an X. So just like the numerator, I can pull out an X. Put in parentheses what is left. So if I took an X out of each of these, I'd have 2x squared minus 11x minus 6. Now, since I have it down to x squared, I can put that part of it in my quad program. So let's see, my zeros of this denominator, if I set that equal to 0 and solved it, it would give me 0. If I put this part in my quad program and solved it, it would tell me 6 and -1/2. All right, so let's use this information to answer all the questions. So remember, the first question that it's going to ask you is what is the domain of this function? And the domain comes from the zeros of the denominator. So again, if you've already done that, you know that these three numbers need to be excluded from the domain of this function, which means not included, okay? This particular problem doesn't make you put it in interval notation. It just wants to know what x cannot equal. So x cannot equal 0, 6, or -1/2. So there's the domain. The vertical asymptote. Now remember where the vertical asymptotes come from, again, are the zeros of the denominator that are not also zeros of the numerator. So since 0 is actually a 0 in the top and the bottom, I do not include this one in my vertical asymptotes, just the 6 and the -1/2. So the vertical asymptotes are x equals 6 and x equals -1/2. So remember what those are. Those are those dashed vertical lines that the graph comes right up next to, but it doesn't touch. Then it wants to know the horizontal asymptote. And remember where that comes. That comes from the degree of the numerator compared to the degree of the denominator. So there's my degrees, the highest exponents. What do you notice? The degree of the numerator is less than the degree of the denominator. So that's when we go to that horizontal asymptote chart that tells us if the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is at y equals 0. The X intercept, or intercepts. Let's see, those come from the zeros of the numerator, again, that are not also zeros of the denominator, which means this 0 is not an x-intercept, because it's also a 0 of the denominator. So your only x-intercept is at -6. So your x-intercept is at -6, 0. And remember, we put it in ordered pair form because an intercept is a physical point that has an x-coordinate and a y-coordinate. The y-intercept comes from what happens if you replace all of the x's in the function with zeros. Well, since every term is an x, if I replace them all with x's, everything turns to 0, including the denominator. And remember, if the denominator turns into a 0, which it would if you replaced all those x's with zeros, that's telling you there is no y-intercept, which is going to be important in this graph. So let's sketch what we know. And a lot of times, just knowing a few of these things helps me decide which graph it is. And I'm going to go with the way that these graphs are doing it. And if you'll notice, they go, all those hash marks on the x-axis are going by 2s. So I'm going to say that mine are also going by 2s. So the first thing I'm going to do is put in my vertical asymptotes. There's one at +6. So if my x, or if they're going by 2s, this will be 2, 4, 6. So there's a vertical asymptote here. There's also a vertical asymptote at -1/2, which means that these are going by 2s, and that's -2 right there. -1/2 is just going to be real close to the origin there. So there's another vertical asymptote. Now let's put in my horizontal asymptote, y equals 0. Well, here's where y equals 0, this horizontal line, which is actually the x-axis. And a lot of times on the previous problems, I've been able to look at my multiple choice options and decide which one my graph would match just by knowing those 3 things. But if I'm looking at these multiple choice options, look at A, it has vertical asymptotes at -1/2 and +6, and a horizontal asymptote at 0. So does B, so does C, so does D. So they all have the same horizontal and vertical asymptotes. So now what I said, as I said, they obviously look all different. Some of them look very, very similar. A looks very similar to C. B looks very similar to D. So I think, well, I have a graphing calculator. Why don't I just put this in my calculator and at least try and narrow it down some more? Now, here's why I want to make sure that you know this. Before you put it in your graphing calculator, is once you put it in factored form, look at these x's. This x cancels that one. So when you put it in your calculator, you do not want to put those x's because they cancel each other out. Also, when you put it in your calculator, since you're, so I'm going to go to my y equals, since you kind of have a lot of stuff in the numerator and the denominator, put an open parenthesis around your numerator and a close, then the division symbol, and then open parenthesis around your denominator and close. So again, in my numerator, I'm going to start off with an open parenthesis. Then all I'm going to put in my numerator is the x plus 6 and close. Then divided by. And again, open parenthesis. All I'm going to put in the denominator is 2x squared minus 11x minus 6. And then close it. And then graph it. So this does help me narrow it down. Because look which one that looks like. It has that upside down parabola, which means it's not B or D, right? Because they have this middle part with that U shape going up. So look at C and A. What is different between those? The only thing that is different is look at that little bitty hole right here. What does this one do instead of having that hole? It crosses through the y-axis, doesn't it? Instead of going to the y-axis, making a hole, not touching the y-axis, and then going through it. That's why it is that one, and why is that? Because when you found the y-intercept, you knew there wasn't one. It does not touch your y-axis. That's what that is telling you. What it does is it comes up to it, and then it puts a little hole on it, and then continues, right? That's what that, it says no y-intercept, so you can't touch the y-axis, okay? So that's why, that's the difference between that A and C, which means that's why you choose the A, because I don't want it to touch the y-axis. Okay, if you type in the original right here, it doesn't take into account that in factored form, some of the numerator cancels some of the denominator. So that's why you need to factor it. And if actually there were more zeros that were the same, I would even need to see this all the way factored out instead of skipping that step and going straight to the zeros. If it had more factors that were the same, I'd have to cancel those too. And it doesn't. And it's because if I knew if this would have made, if I factored this and it made an x plus 6, how would I know that? Well, I would have another same zero here, which I don't. So that's how I knew there weren't any more factors that were going to be the same and need to cancel. Okay? All right, so that's the end of 8.5. Now we're going to do 8.6, which is much lighter, and I'm going to teach it completely different than what Math Lab teaches it and save you a ton of time. We're going to talk about what these problems look like on a graph instead of written out on paper. So what 8.6 is talking about, it's going to have the graph of a bunch of parabolas, which is the U shape. And it's going to ask, where is the graph above or below 0, greater than or less than 0? So let's talk about what that's asking us first. Okay, I'm just going to draw a random parabola here. Where is 0. What tells me what 0 is? The X, remember what words are the same as zeros? Zeros, solutions, X intercepts, all mean the same thing, which means this point and this point are equal to 0. What is 0? Your x-axis is 0. That's your 0. So if I wanted to know where this graph, we'll just say, is less than 0, what does that mean? That means where is the graph below, right? That's what less than means, is below 0. Well, it looks like it's, here's my, if this is 0, it's below 0, all that spot right there. Because once it, this is 0, so once it gets there, it goes above 0. So this we'll call, this is called an interval, is where it would be below 0 or less than 0. So what do I need to know about this parabola? I need to know what these points are. What are the x's there? What are those x's? Those are the x intercepts, or the zeros, and I need to know what they are so that I can name that interval and say, this graph is below or less than 0 from here, this x to this x. Okay, the other thing I need to know before I get into these problems, sometimes a parabola is U-shaped like this. Sometimes the parabola is upside down like that. So what makes one look like this and one look like that? Well, you are regular right side up if you are positive x squared, right? If you are negative x squared, the negative x squared is what makes your parabola flip upside down and be this shape. So those are the two things I'm going to need to know about each of these graphs. Where are the x intercepts? And is it regular U-shape or upside down U-shape? So let's look at number 1. X minus 2 times x plus 3. Where is that less than 0? So again, that means where is this graph? If I graphed it, where is it less than or below 0? And 0 is your x-axis. So where is it below the x-axis? Number 1 is nice. It's already got it in factored form. How do I even know this is a parabola? I don't even see an x squared. But what do you know? If I FOILed this, what would be the first thing I would get if I multiplied these two parentheses together? I'd have x times x. There's your x squared, right? So this does make a parabola, which means now I need to know where are the x-intercepts of this parabola, or the zeros. Well, it's already got it in factored form for me, so since I see the factors, I'll just set them each equal to 0 and solve them for x to see where this parabola is going to have x-intercepts. So let's see, if I solve this one, I'd have to add 2 to both sides. So x equals 2, which means it's going to cross the x-axis at 2. This one, I'd subtract 3 from both sides to get x equals negative 3. So let's see, what does that look like on the graph? Remember, there's your 0, the x-axis. It's going to cross through the x-axis at positive 2 and at negative 3. Now all I need to know, is it regular right side up or is it upside down? If you multiply these x's together, are you going to get a positive x squared or a negative x squared? Well, x times x is positive x squared. So all I need to know, I don't even know how far down it goes or anything. I just need to know that it is right side up. And it crosses through at negative 3 and positive 2. Now, does the question ask me where it's above or below the x-axis, which just means you need to look at this side. So since it says, where is this graph less than 0? So if this is 0 and I'm less than it, that means I'm below it. So it's less than 0 in that interval right there. Which means from this x to this x, it is less than 0. Now, I want to use parentheses around my interval because it doesn't have an equal to sign, right? It doesn't say less than or equal to. If it has equal to, then I would use my brackets to include those numbers. But since it doesn't, where does it start being below 0? Right here, which is -3. And it's below 0 all the way until it gets to 2. So -3 to 2 is where it is below 0. So again, find your x-intercepts, put them on the x-axis, sketch a real rough parabola. You just need to know whether it's right side up or upside down. And then say, okay, does it want to know where it's above or below 0? So you just go and you look at your less than or greater than symbol. Okay, let's look at number 2. X squared minus 14x plus 33. Let's see, it wants to know where is that greater than 0, so above 0 this time. Now, this isn't in factored form like that last one was, so I can either put it in factored form, or what am I trying to find? I'm trying to find the zeros of an x squared problem. I can always go to my quad program for that, right? So if I don't have the quad, then I'm going to have to factor it. So the x and x for x squared. Factors of positive 33 that add to -14 would be a -11 and a -3, right? Multiplies to positive 33. -11 plus -3 adds to -14. So there's your factors. What do we get from factors? Well, if we set them equal to 0, we're going to get zeros. Let's solve them. So add 11 there. So x equals 11. So it's going to cross the x-axis at 11. Here I'll add the 3 to both sides. So it's also going to cross the x-axis at positive 3. And again, your graph doesn't have to be exact. There's only really 2 things you need to know: where it crosses the x and whether or not it's upside down or regular. So let's just say, I'm going to make this really rough. It's going to cross the x at 11 and 3. So I'll say there's 11, there's 3. That's where it's going to cross, at 3 and 11. Is it right side up? Yes, right? It's not, the x squared isn't negative, so it didn't flip upside down, which means it's going to look like this. This time it wants to know, where is the graph greater than 0? Well, if there's your 0, where is it greater than? It's going to be above the x-axis. So this time I'm talking this interval and this interval is where it is above 0. So I'm talking 2 separate intervals here. I'm talking, where does this start? If this arrow goes forever to the left, it's going to start at -infinity until it gets to this point, which is 3. So -infinity to 3, it's above 0. Then it goes below 0 for an interval down here. So it's below 0. Then once it gets to this point, it goes back above 0. So what is this point? It's 11. So, and 11 to infinity. So those two intervals, it's above 0. All right, number 3. X squared minus 3x minus 30 greater than or equal to x minus 9. So before I can find zeros or x intercepts, which is what I need to know about this parabola, what does this side need to be? It's going to have to be 0. So before I can go to my quad or factor it, however I want to get to my zeros, I've got to set it equal to 0. And I can do that all in one step. I need to get rid of x, so I'm going to subtract x here. If I subtract it there, I've got to subtract it on the left side. Make sure when you subtract x on the left side, you put it underneath its like term to keep your work organized. So I'm going to put it here, minus x. What else do I need to get rid of over here? I need to get rid of that minus 9, so I will plus 9. Well, plus 9 there, I got a plus 9 on this side, again, under its like term. So now, bring down my symbol, greater than or equal to. I have nothing over there, which is what I wanted. Let's see what I have left on the left. I have x squared. Negative 3x minus x gives me negative 4x. Negative 30 plus 9 gives me negative 21. So again, I can factor that or go to my quad program, right? So program down to quad. Put in your A, B, and C, which in this case are 1, negative 4, and negative 21. There's your zeros. 7 and negative 3. All I need to know, right? That's what are zeros. Those are x intercepts. So it's going to cross through the x-axis at 7. Let's call that 7. Call that negative 3. There's my x-intercepts. Is this a right side up parabola? It is. There's no negative in front of the x squared, so I know it's right side up. What is the question asking me? Where is this parabola, this graph, greater than or equal to 0? So again, if this is 0, it's greater than or equal to above it here and above it here. This time though, it's greater than or equal to, which means I do want to, it wants to find out where is it above negative 3 and equal negative 3. Again, equal 7 and above 7. So I want to include all of that. So now I'm going to put brackets around the negative 3 and the 7, but not around infinities, right? Infinities don't ever have brackets. They're just always parentheses. Okay, so where does it start being above 0? All the way to the left until it gets to negative 3. So negative infinity to negative 3 with a bracket to include that negative 3. And let's see, it drops below until it gets to 7. And then it starts being above again. So from 7 to infinity. And again, the 7 will have a bracket. Infinity will have a parentheses. All right, number 4, x squared is greater than 4. So let's see, solve it for 0 first. So I need to subtract the 4 from both sides. So there's my greater than 0. Over here, you can't put those terms together, right? One's an x squared, one's a constant. They're not like terms, so you'll just bring down the x squared and the minus 4. So you can either factor that. This is a simple factoring problem, right? It's difference of perfect squares, which just means if you factor it, it's going to be x plus 2, x minus 2. If you set those equal to 0 and solve them, this 0 would be negative 2, that 0 will be positive 2. Now, I could have taken this 2 by quad program, right? It is x squared, but if I do that, it's always going to ask me A, B, and C. A is always the number in front of x squared, which is 1. What is your B? B is not just the next number in the list of terms. B is the number in front of your x. Well, if I'm looking here, I don't see an x, which means I need to put in a 0 for my B. C is always the constant, which is the number that doesn't have a letter hooked onto it, which is negative 4. So if you put that into your quad program, it's still going to tell you negative 2 and positive 2 as your zeros. So what do I know? It's going to cross through the x-axis at negative 2 and 2. So negative 2, positive 2. And then I just need to know if it's upside down or regular. Let's see. It's regular x squared, which means it's a regular straight up parabola. And what does it want to know? What's it asking me? Where is this parabola or this graph above, greater than 0? So again, above 0 in those two spots. Do I use brackets ever in this problem? No, it doesn't have the equal to bar, which means it doesn't want me to include the negative 2 and 2. Just wants to know whether they are above them, not equal to them. So let's see, what is this interval? Negative infinity to negative 2. In union with, what's the other interval? Let's see, below here. Once it gets to 2, and then forever, it is above the x-axis again. All right, number 5. (225 minus x squared) less than or equal to 0. I'm going to put this in my quad because I want to make sure that you understand what numbers to put in for your A, B, and C. And there will be work to do to factor that. I'd have to rearrange the terms, plot a negative, and all kinds of stuff. So let's see. What is A in this situation? What is the number in front of x squared? Well, here's my x squared. Here's the number in front of it, which would make it negative 1. What's the number in front of x? Do you see an x? There's not an x, which means your B is 0. C, what's your constant? It's positive 225. So let's see, if you put that in your quad, what are your zeros? Negative 1, 0, and 225. If I put that in, it tells me 15 and negative 15 are my zeros. So let's see, I'll just call this negative 15, that positive 15. So there's my X intercepts. What's happening with this parabola though. Look at your x squared. What does this do to the parabola? Flips it upside down, which is going to be important here. If it flips it upside down, it's an upside down U. What does it want to know? Where is this graph less than or equal to 0? Well, less than 0 is below it, right? If this is 0 and I'm less than it, I want to know where it's below it. So again, two separate intervals. And I'm including the negative 15 and positive 15, right? Because of the equal to bar. So let's see. Negative infinity to this point, which is negative 15, and including, because of the equal to bar, in union with, then it goes above, greater than 0 here, until it gets to this other 15, where it goes below it again. So again, it starts being below at 15, and then it's below forever to infinity. All right, two more. Number 6, 22x minus 121 minus x squared less than 0. So it's already set equal to 0. It's quad since it's squared. So I'm going to go ahead and put those numbers in my A, B, and C. What is your number in front of x squared? It is negative 1. B, what's your number in front of the x? Well, here's my x. So the number in front of it is 22. C is your constant, which is the number without the x, so negative 121. Let's put that in our quad and see what happens and what that means. So again, A is negative 1, B is 22, and C is negative 121. Look what it tells me. My zeros are 11 and 11, which means this actually only has one X intercept at 11. So what makes that happen in a parabola? So there's where 11 is. That's its only x-intercept. Now, is it upside down or right side up? Well, x squared is negative, which means it's upside down. So if it only has one x-intercept, that's where it comes. It touches the x-axis right there and then goes back the other way. It doesn't cross all the way through it, because if it crossed all the way through it and had to come back down, it would cross it again somewhere, have to cross it again somewhere else. Okay? But it only has 1 0 at 11. So that's what it would look like. Now, what is your graph, or what is your question asking me? Where is it below 0 or below? It's below 0 everywhere except 11. Right? It's not below 0 at 11. Here's where this right here is 11, and it's not below 0 there. That equals 0. If you're the x-axis, you are the 0. So I want to show everywhere below 0 is this interval and this interval, or in other words, everywhere except 11. Which would mean what? Negative infinity to 11. And 11 to infinity. So everywhere below 11 and everywhere above 11, just not 11. right, last one, and this is going to give us a couple of things I want to explain about in the calculator. You have x squared plus 18 is less than 4x. So before I can try to graph this or put it in my quad to find my zeros or anything, I need to set it equal to 0, which means get rid of this by subtracting 4x. If I do it over there, I have to do it over on the left side. I'm going to scoot that minus 4x in between the x squared and the 18, just so that my terms will be in the right order. So let's see, over here I'm going to have less than 0. Here I'm going to have x squared minus 4x plus 18. This one I'm going to use my quad program. Even if I tried to factor that, I would see it doesn't factor, which means I would have to go and use the quadratic formula if I didn't have a quad program. But since I do, I'll use it. Put in my A, B, and C, which will be 1, negative 4, positive 18. Look what it gives you. Something we hadn't seen before. This says 2 plus I square root of 14 and 2 minus I square root of 14. What are you finding here? You're finding X intercepts. Well, your answers just gave you numbers that are not on a number line because they're I's, which means this shouldn't cross the x-axis. Why wouldn't it cross the x-axis? Now, here's the thing I wanted to show you on the calculator. Let's put it in our y equals and say to ourselves, why in the world does this not have any x-intercepts? So go to your y equals, clear it out. Let's put this in. X squared minus 4x plus 18. Now, if you graph it and your graph is still on the standard, which it probably is, which means your x-axis goes from negative 10 to positive 10. Your y-axis goes from negative 10 to positive 10. Well, I put my function in there and I hit graph, but I don't see it. Well, what that means is that it's just not in this window. So I want to change my window to make my x-axis go farther this way and farther that way, and my y-axis to go farther down and farther up. So go to your window right here. So here's why your window shows what it shows. It's saying you want the x minimum, the minimum value on your x-axis to be at negative 10. The maximum value of your x-axis to be at positive 10. This means your x scale. That means you want your hash marks to go by ones. Same thing for your y-axis. You want the bottom of it to be at negative 10, the top of it to be at positive 10, and you want your y's to go by ones. That's why your graph looks like that. Negative 10 to positive 10, negative 10 to positive 10, and each one of these hash marks is a 1. So I just don't see it in that window. So what I'm going to do is make my window bigger. Okay? I'm going to say, you know what? I want my minimum x to be negative 40. So let's see. Then I want my maximum x, I'm just going to change it to positive 40. Still want them to go by ones. Let's do the same thing with my y's. Let's make it go from negative 40 to positive 40. So negative 40 is the y min, positive 40 is the y max, and I'll still have it go by ones. Now let's graph it. See how your x-axis and y-axis did what they did? They just made it, all the hash marks are teeny tiny small, because this goes from negative 40 to positive 40. So I got to get 40 hash marks in there. Look where your parabola is. why did it not tell me where the zeros were or the X intercepts? What does it not do? It doesn't touch the x-axis. It doesn't cross it. So now I need to say to myself, well, does it want to know where my graph is above or below it? Because if it asks me where it's above it all the time, from negative infinity to positive infinity. But if it asks me where it's below the x-axis, that means below this line right here. Here's my parabola. It's not ever going to be below it, right? It comes down here. There's the minimum of it, and then it goes back the other way. It doesn't ever go below 0. So let's see, what's it asking me? That's what it's asking me. Where is this less than 0 or below it? It's not. It's never below it. So your answer is just this symbol right here. It's called the null set, and it'll be down in your toolbox on that problem to answer it with that. That just means you asked me where it was below 0, and I'm telling you that this is not ever below 0. Okay? Now, your graph, your window is going to stay like this forever unless you change it. So a lot of times that -10 to +10 situation is what you want. So to get back to that quickly, you can always do zoom and see how this number 6 is standard. So that -10 to +10 is standard. So just go down to 6 and hit enter, and look what it does. It puts your x-axis and your y-axis back to the standard. That's why I can't see that graph anymore, because remember, it's up here somewhere. Okay, so again, zoom 6 will get you back to standard. And if you ever can't see a graph, then just change your window. Okay, so that is the end of 8.6. And that is the end of today. So y'all have a good weekend, and I will see you on Monday.